In this video, we're going to talk about transformations of lines. There are several transformations: translations, reflections, horizontal compressions and stretches, and vertical compressions and stretches. Go ahead and get your notes started. There's going to be a lot of objectives and many new vocabulary words. Don't forget to rank your words with an X, a check mark, and a circle depending on how much you know about them. And also don't forget to go back at the end of the video and re-rank your words. Remember that an X is that you know a lot about the word, a check mark is that you know a little bit, and a circle is that you have no idea. Pause the video if you need to finish getting your notes ready. The first kind of transformation that we're going to talk about is a horizontal shift. When you want to move left or right, it's the input value that changes. So a horizontal shift is the input value change. If x is greater than 0, we're going to move to the right, and if h is less than 0, we're going to move to the left. So basically, we're moving our line left and right. So we're going to let g of x be the indicated transformation of f of x, and we're going to write the new rule for our function. So in these two examples, we're going to use the same function f of x all the way through this video. So we're going to start with a line 3x plus 1, and we're going to translate it 2 units to the right. So what this rule up here says is that what we do is take our translation and stick it in just for the x's. So our new function g of x is going to be f of x minus 2, okay, is what we're going to do. So then what we do for g of x is we're going to take 3, and instead of just having an x there now, we're going to put x minus 2, because we're translating it 2 units to the right, plus 1. Because up here, that's what it says to do, x minus h. Now all you have to do is simplify. Well, distribute 3 times x and 3 times negative 2, so 3x minus 6, and then don't forget about that 1 because our original function had a 1 in it, plus 1. Well, that equals 3x minus 5. Okay, this translation wants us to go 5 units to the left. So g of x is our new function, and f of x minus negative 5, because 5 units to the left would be negative 5. Well, that's going to end up being f of x plus 5. So then what we're going to do is 3 times x plus 5, and don't forget about the 1 on the end. So we would take 3x plus 15 plus 1, and that would equal 3x plus 16. So up here I should have written our new function g of x equals 3x minus 5, and down here our new function g of x equals 3x plus 16. So remember that on a horizontal shift, that our input value was the only thing that changed. For vertical shifts, when we want to move up or down, the output value changes. So all we're going to do is add a number to the outside of our function. So remember I said we're going to use the same function. So 3x plus 1, we're going to translate it 2 units up. So to translate it 2 units up, then what we're going to do for our new function g of x, what we do is we're going to take f of x and add 2. Well, to get g of x then, what we need to do is take our old function f of x, which was 3x plus 1, and just add 2, because that's what the rule says. You take f of x and you add your number. So our new function g of x would be 3x plus 3. So g of x equals 3x plus 3. If we want to go down 5 units, g of x would be f of x minus 5. So g of x would be 3x plus 1 minus 5, because I'm taking my old function and taking 5 away. So g of x would equal 3x minus 4. So I'm just moving down 5. So vertical changes are fairly simple. You either go up a positive number or down a negative number. When you want to reflect across the y-axis, you change the input value to the opposite sign so that the line becomes symmetric across the y-axis. When you want to reflect across the x-axis, you change the output values, or you change the signs of the whole function, however you want to think about it. So reflecting across the y, you change the input value. Reflecting across the x, you have to change the whole function. Okay, so let g of x be the indicated transformation of f of x. Write the rule for g of x. So if we want to reflect across the y, remember I said we just change the input. So for g of x, we're going to only change the input. So we only change the x sign. So to get g of x in this situation, we would only change the x value. So that's only this piece. So our new g of x would be negative 3x plus 1. So that's a reflection across the y-axis. To get a reflection across the x-axis, it says we change the sign of the whole function. So to get reflected across the x-axis, for g of x, we're going to change the entire function f of x. So to do that, we're going to change the whole function f of x. So then we are going to take and change every sign of f of x. So that would be negative 3x minus 1. Okay, now stretches and compressions change the slope of a linear function. If the line becomes steeper, then the function has been stretched vertically or compressed horizontally. If the line becomes flatter, then the function has become compressed vertically or stretched horizontally. Now here's a helpful hint. These don't change. Y-intercepts don't change in a horizontal stretch or compression, and x-intercepts don't change in a vertical stretch or compression. Okay, so for a horizontal stretch or compression by a factor of b, the input value changes. So what we're going to do is take 1 over b times our input value. If b is greater than 1, it stretches away from the y-axis. If b is between 0 and 1, in other words, if it's a fraction or decimal, it compresses towards the y-axis. If it's vertical, stretch or compression by a factor of a, we take the whole function times a factor of a. If a is bigger than 1, it stretches away from the x-axis. If it's a decimal or a fraction between 0 and 1, it compresses towards the x-axis. Okay, so here's a couple of examples. First, we'll do a horizontal stretch by a factor of 4. So what we do is take this factor and we only change this piece right here of the function. So to get g of x, then we take 3 and we take this factor piece right here times 1 over b, which is our factor, times x plus 1 out here. Because remember, in horizontal stretches, right here, it's only the x that changes. So our new g of x is 3/4 x plus 1. So our slope changed, but not our y-intercept. So horizontal stretch by a factor of 4. Okay. Okay, now f of x equals 3x plus 1. We want a vertical compression by a factor of 1/3. Okay, what that means is we're taking the whole entire function, because it's vertical, times 1/3. So we're going to take, to get g of x, 1/3 times our entire function, f of x, because it's vertical. So that means our new g of x is 1/3 times 3x, which is x, and 1/3 times 1. So our new g of x in this vertical change is now x plus 1/3. So our whole function changed. Okay, so notice that anytime we're dealing with horizontal changes, that it's only the x piece that changes. Anytime we're dealing with vertical changes, it's the entire function that changes. Okay, so this is the end of part 1 of translations. In part 2, I will just do more examples.